Distinct substances can be categorized as either acidic, neutral, or basic based on their physical and chemical properties. The knowledge of acids and bases is very significant as they are encountered by members of the society on a daily basis. The adequate neutralization or dilution of these solutions is substantial when it comes to preventing accidents, due to the fact that the combination of particular compounds may be hazardous. Throughout the centuries, scientists have developed distinct methods to explain acidic and basic solutions. Hence the fact that there are three most commonly known types of acid and base theories, which are Arrhenius, Bronsted-Lowry, and Lewis. These concepts are all suitable for distinct circumstances. Svante Arrhenius was a Swedish scientist that proposed and established the Arrhenius theory of acids and bases in 1884 as a fragment of his doctoral thesis. Weak acids are defined as solutions that ionize partially in a water substance due to the fact that most of the molecules in this type of acid remain intact. Examples would include acetic acid, which is vinegar. Strong acids are substances that absolutely ionize when dissolved in water. The concentration of ions per molecule produced by a strong acid is high. Examples would include the binary acid HCl and the oxoacid H2SO4, which is found in car batteries. The following chart depicts the most common properties of acids. A weak base is a substance that forms very few hydroxide ions in a solution of water. An example would include ammonia. A strong base is defined as a substance that entirely dissociates in the presence of water to generate hydroxide ions. An example is sodium hydroxide. The following table shows the properties of bases. Neutralization is a double displacement reaction which involves the process of making a solution neutral by adding an Arrhenius acid to an alkaline solution and vice versa. In this chemical reaction, the solutions interact and generate water as it involves the combination of hydrogen ions and hydroxide ions. It also results in the formation of salt, due to the fact that the anion from the acidic solution and the metal cation from the basic solution mixed. The concentration of either reactant that experiences a neutralization reaction can be identified if the volumes of the acid and the base have been determined and if the concentration of one of the solutions is known. For instance, one may conclude the concentration of a basic aqueous substance by following these steps. First, figure out the balanced chemical equation for the reaction. Then, determine the amount of acid by utilizing the formula N equals C times V, where N is the amount of the base needed to neutralize the acid, C is the molar concentration of the acid, and V is the volume of the acid. Subsequently, determine the amount of the base needed to neutralize the acid by using mole ratios. Next, substitute the values into the formula C equals N divided by V to calculate the concentration of the basic solution. The performance of a neutralization reaction by completing titration is another method used to find the concentration of a substance. An indicator is used to signal the conclusion of a titration, which is known as the endpoint. Specific tools are used for this procedure, such as a graduated pipette, volumetric pipette, and a burette. Dilution is the process of adding more solvent to a solution, therefore reducing the concentration of a solute in a substance. The general formula for calculating dilution is C1V1 equals C2V2. C1 can be determined by finding the concentration of the acidic solution. V1 refers to the volume of the acid that will be added to H2O. The desired concentration and volume of an acid is typically determined by the problem presented to you. Therefore, the term C2 refers to the diluted solution's concentration and V2 refers to the diluted solution's volume.
Created using Powtoon.